All right, well, this week we did two labs, Cart Lab and then Cart Lab 2, which is up there. The difference on them is that we changed our wheels out. So right here for the question, they said, will my cart travel faster with skinny tires? And we used several of that. We have the, this was all published on here so you can see that. If you're working from at home and you're trying to do this one, it can be done. Might take a little bit of creativity on it. This is the Cart Lab itself that we had for the chart, and as you can see, we have the weights on here: 0, 1, 2, and 3. If you only had a couple of different weights options you could do, that would be just fine. The key here is to look at how it will be when we add weights. Now, we were able to change tires. That might be a little bit more problematic. But if you're doing it on the for the carts, if you've got Lego tires, take some smaller ones first and then some bigger ones. Or if they have rubber tires, if you can take them off and run it on the rims and see that way. Two different ways that they can see it, and they can see how it's going to work. Their hypothesis should reflect that. Now, ours were set up on this for a hypothesis would have been for this one here that most of the ones that I heard from the kids were, my hypothesis is, or I think that it will go farther with the skinny tires because there will be less friction, and that is a very sound one to give. Okay, then we also we'll get back to the graph in just a minute. But now we set up the ramp here, and so we used a larger ramp because we wanted to get a little bit of speed here. This could be done in a number of places. As you can see, my ramp is right out of the parking lot. Dr. Jones, several years back, was willing to said, hey, you can use that when I asked him for it. Now, we used two carts. This is the one with the bigger wheels, and we used the little smaller wheels as well. And they found the first day I, quote unquote, accidentally had the children, one of the children have a larger tire, not the same like this that's all smooth, but a larger studded type tire that was the other ones. And it just was luck of the draw. So one kid seemed to have one that went a lot farther than everybody else's. Now, we set it at the top here, and they rolled it down the ramp and across the floor. And then I called their measurements out for them. Like this one here happened to go 18.5 feet. We did this 3 times. Then we added another marble to it. So we're going to take a marble. When I say a marble, I'm talking about a big steel sphere here. They're pretty good size. And we did the same thing. We walked over and they set it up here on the ramp, like so, and they rolled it down. And this one here looks like it's going to hit the wall. Barely, but it did. And that happens to be at the 20-foot mark. So this one went to 20 feet. So they would have done this 3 times, and if you notice, the first one went 18 feet, second one went 20 feet when we added a marble. So what happens when we add another one? Well, the kids were, at this time, kind of realized, some of them that had thought, well, maybe it's not going to go as far, realized that this is indeed the case, what's going to happen. So they went ahead and added a second one. We'll go ahead and do that right now. As you can see, it's a pretty simple cart operation that we made for this. And this one hopefully won't go into the side there, but we'll see. We had quite a few crashes. Okay, that one's going to go alongside the wall there. And with the extra marble, this one went over 20 feet. Just a few more inches for 2. And they did that a couple of times. Some of them went fairly well. Some even went out the door by this point. Our doorstep right here is at 24 feet. Right there is 24 feet. So if it hit the wall here solidly, which many did, then we considered that 24 feet. We had many that went out into the hallway, and we'll see how this works with 3. Okay, 3 weights, and you'll see the difference on it. And this is what I was hoping the kids will get a chance to see and do. And hopefully I won't splatter this into the side. This is very difficult because you have to make sure it gets down that ramp smoothly. And here we go. So cross your fingers. There it goes. Uh-oh, it's starting to pull toward the side there. And with 3, it didn't go much farther. So that's the case on this one. Some of them did go considerably farther. And sometimes it may be other factors could be on there. Maybe the way they put it together. This is kind of a little wiggly waggly on there. So in addition to that, I showed them some other vehicles, and I did that for them. Let's see, we have the Robin. So Robin went on this one here, and so we built this. This one here has, you can see, 3 big weights on it. These are actual Lego weights. They're not quite as heavy as the other one. But again, these are larger tires, and it's a longer vehicle, and it's very smooth because it's the rubber tires. And we'll see if this one will get out the door. Okay, just so you can see. Nice and smooth, and there it goes across the hall, and boom, hits the wall at 36.5 feet, and then bounced back about another 1.5 feet. So that's, had it been free to go, it probably made it 40 feet or better, and very smooth and all that. The students would like me to this on Monday or Tuesday, or Wednesday and Thursday, one of those days, and I'll probably do that for them. We're going to set up the ramp here instead of putting it on my little cart there, my little orange art cart. I'm going to use it on a step ladder that I have so I can get it a little bit higher. They want to see if they can get something to go all the way down the hall. Okay. So he did his job and got across. We also looked at some other reasons they maybe went farther. This one here is filled with weights underneath. And that's about 300 grams worth. Yeah, about 300 grams worth of weights inside of this. And it's using larger wheels without any tires on it. So the kids realized that this would give it the least amount of friction, and this would roll it. Now what I'm looking for them to do, and you guys to do, is to say, okay, let's see how this works. Now I started this a little lower because, gosh, it's pretty darn heavy. But again, this one here turns and, ow, slams into the wall there, spins around at 24, and I haven't added any additional weights on it. But for the kids, we went ahead and did that and added some more weights just to see how well this one could work. And without destroying it, I already broke 2 of these wheels right here, snapped them clean, because the amount of mass hitting the wall. These were really, our cart lab is another name for a momentum lab. So I'm going to start this halfway down the ramp. Okay. And here we go. And it looks like it's going to hit wall, and it broke up. Well, this happened to a lot of the peoples there. And they didn't seem too sad about it, because the good thing about Legos is that if it falls apart, they can put it back together. Okay, and so they did and did until they tried them, and some kids went farther than others. Nothing wrong with that. I personally feel that it's more seeing how once they change the weight or they change the type of tires, this is what we were looking for here. And bag of carts or box of carts here, they did a pretty good job. And so I hope if you do this one at home, or if you've done it, if you did it here, there's no reason that you can't do this at home. You could make a ramp, larger ramp. You just have to have a relatively smooth surface for them to ride on. So if you've got a place in the house and you have mom's permission or dad's permission or what have you, go ahead and feel free to do it. Okay. So once that is all done, I know on the one I did with my with my big one there, even before I added weights on it, it was able to go 36.5 feet, which was running it into the wall. But let's see what we can do here. Got my pen. Okay, we'll grab a Sharpie here. And we can come over here, and the doorway was right at here at 24 feet. And so a lot of the kids got them to go actually out into there. So with the 0 weights, they'd go ahead and do this, and using a ruler, they'd mark up there what the average was. They do the averages first, with 0, with 1, with 2, and they could have done with 3. And so they have another spot for it. They did this one distance in feet, but there's no reason you couldn't do it in meters or in centimeters as well. Okay, if they don't have the same surface. But to do this one right, I would say the best thing would be to really up the amount of force behind it and up the amount of mass in the vehicle. So a couple of changes in there will make a big difference. I think you saw there that when you did change the mass or the size of the vehicle, it really does make a difference. Okay. So there you go. That was the nuts and bolts of the CART Labs, plural. Now, just as a reminder, don't forget these labs all need to be completed, written up. So you're looking for, must have your graph and your action. What are you going to do next? Now, when we did CART Lab 1, the action was, I already gave that to you, and that was to say that I'm going to do this again, and I'm going to, and you can write that like right here, and then I'm going to change out and have skinny tires. But you could have also added more weights. You could have done anything on there. And the same with this CART Lab 2. Well, how are we going to do that? Well, maybe I'm going to use it with some other form that you're going to do. If you remember the lab or the activity that I sent you, where you could roll a jar with stuff in it, you could just keep adding, getting some more mass in it. Maybe you roll it up a little bit higher and see how that works. That would work just as well as this did, and it should come to the same conclusions. Now, my question to everybody on this one here was, why did it go farther when it had greater mass? And that's still the question on here. Maybe I'll reveal it next week.